So the first session this morning, it's about the accelerating adoption of AI and manufacturing. And this session's being hosted by the Digital Catapult. So first of all, we have a 20-minute fireside, and I'll explain who that is in a minute. Then we're going to have a panel, and we're really talking about AI in manufacturing. So first of all, I want to understand a bit more about you guys in the audience. First of all, can you hear me in the back? I just want to make sure you're okay. Okay, perfect. How about back at the escalator? Can you hear me way back there? Yay, okay, good. I've got a loud voice. I wanted to know a little bit about you as an audience. Who are you guys? So how many of you are founders, for example? Okay, few founders. How many of you work in government? Okay, some of you. Manufacturing? So actually in the actual industry? Students? A few. Scientists? Oh, we got a couple, okay. So we've got a pretty good sort of mixture of people. Who have I missed? Service providers, like lawyers, accountants. Oh, we got one lawyer, okay, watch out for him. Sorry, did I choose? Yeah, he's right there in the second row over here. Service provider, okay, fine. Okay, so with that, the first 20 minutes, we're going to do the fireside, and it's between Jeremy Silver and Juergen Maier. Now, Jeremy is the CEO of the Digital Catapult, and Juergen, amongst the many hats he wears, is the chair of Digital Catapult, as well as being the CEO of Siemens UK. Now, I love to introduce speakers by getting a quirky fact about them. So this is what I've learned from Jeremy and Juergen. So Jeremy knows how to play a zurna. Do any of you know what a zurna is? No? Okay, there's no Turkish people in the audience, fair enough. It's a Turkish wedding march instrument. Looks a bit like a clarinet with no keys. That is really random. How did you learn to do that? Bless. And then Juergen, took him a bit of time to figure out the good quirky fact. I was inventing stuff like, he's going to Mars and never coming back, but he wouldn't let that happen. So before business, he was a budding amateur dramaticist. So there we go. So with that, Juergen and Jeremy, please come to stage.
Thank you so much. Good morning, everyone. And
I feel like we should be playing a musical instrument and a bit of drama, actually.
Well, I hope we're not going to have any amateur dramatics this
morning.
No. You never know. You never know. I think we've heard a little bit about the amazing move of this session into this tunnel, but it is the funkiest, grooviest lit conference venue I think I've been in for a while. So it's great. So I hope everyone can hear all right. Juergen has been working for Siemens actually almost your entire career, as I understand it, which is an extraordinary achievement. And obviously in that time, you've seen huge amounts of change. And you've became the CEO in 2014, is that right? Yeah. And so even in that period, we've probably seen an immense amount of change. And then very recently, we were delighted when you also agreed to become the chair of Digital Catapult. For those of you that don't know, Digital Catapult is a lab for business. We run programs in virtual reality and immersive technologies, in infrastructure, digital infrastructure and future networks, and also in machine learning and AI. And one of our programs, the Machine Intelligence Garage, is represented in a booth somewhere on the this sort of spread out campus that we're all exploring, hopefully a little bit more dryly today than yesterday. The other thing that distinguishes Juergen, in addition to his incredible CV, is that he was also invited by Greg Clark about a year and a half ago, I suppose it is now, to start to do something called Made Smarter, which is an initiative to really look at digitalization opportunities in the manufacturing sector. And Made Smarter has developed and has grown as an initiative. There are about 400 companies that have got behind it and got involved. They published an extraordinary report, which is an incredibly valuable document, which I haven't got here because it's the size of a small doorstop, but it's really a great resource I'm sure there's a PDF that's downloadable as well. And in all of that, I suppose you could sum it all up by saying that Juergen's probably the UK's strongest advocate for what is sometimes called the fourth industrial revolution. And at this weekend, I was told, because I'm not a Daily Telegraph reader, but at the weekend there was a Telegraph feature all about Juergen's comments on industry more generally and about some of your ideas around responsible capitalism. So we might come back to that. I'm interested in that. But perhaps just to start off with, could I just ask you, this conference is all about AI. There's an incredible buzz around AI. From a traditional manufacturer's perspective, what's your view about how this technology is really going to have an impact, and where is it going to be felt, or where is it being felt already?
Yeah, there are two answers to that question, I think. And one is the impact it is beginning to have and is already having is going to be huge. And your point about the change of pace of technology is really quite remarkable. When I think of the company Siemens that I've worked for 33 years, the pace at which we are evolving technology, especially in this space of Internet of Things, data analytics, big data, machine learning, it's quite unbelievable. We've got products in the market today that we didn't have in our sort of roadmap 5 years ago. And for Siemens, that is quite unbelievable. We were used to technology roadmaps of thinking 10 years ahead, and all those days are smashed. This is disruption at one incredible pace. So it is having a big impact. The problem we have, I don't know whether we can turn the feedback down a little bit. The problem we've got is that manufacturing industry is struggling to adopt at pace. And that's why we need great activities like the Digital Catapult. We need better ecosystems. I'm sure we'll come back to all of that. Having said that, there are some areas that are happening at faster pace than others.
You've been quite instrumental in trying to bring in some of that into the real world, because so much of what we talk about is still, somewhat sort of future vision, isn't it? But you've really put some of this into practice already in some of your factories, haven't you? Can you tell us a bit about those?
Yeah, we have indeed. Well, not just in our factories. I mean, the one that is furthest advanced, I think, in a lot of factories is the whole area of predictive maintenance. And so that is using data from sensors on machines, putting it into the cloud and using cloud-based intelligence based on those same applications, could be anywhere in the world, to help predict whether what is being seen on that machine now is likely to be a critical failure. Actually, the last time the data analytics or the data saw that, it just shook itself out and it wasn't a problem at all. So that sort of predictive analytics is beginning to take hold quite fast. Why is that? Because the business case is huge. If you can really smartly predict when a process is going to fail or not and intervene before it fails, I mean, the business case is obviously huge.
And are there savings, you think, that are already being seen as a result of that?
Oh, 100%, yeah. I mean, you take an industry, offshore wind, an industry that we're in a lot, where we are applying this technology very much so, and to be able to predict and to intervene at exactly the right point is a huge cost saving, because these things are sort of increasingly 100 miles off the coast, and you don't want to be the thing to be breaking down and then quickly having to go and do a fix. So to be able to do all of that in a very predictive way has been a key part of us being able to bring the cost of that energy down.
So if you think about the kind of the process and production processes in different kinds of factory environments, I mean, predictive maintenance is obviously working and really starting to kick in, although it's probably true to say it's still only in tier one companies, isn't it? Are there other aspects of manufacturing processes where the opportunity is even greater, do you think? Or, I mean, is that necessarily the biggest one, or are there other places where there's opportunity as well?
Yeah, well, I mean, a couple of questions, answers to that. The first thing, I don't want to, sort of promote here that this is only for tier one companies. Something like predictive maintenance, we are showing in certain applications you can do very cheaply, very effectively, few sensors, cloud-based platform, and you can do it. So increasingly small to medium-sized companies are coming on board too. There are numerous areas, but the other two that maybe I would just quickly highlight is one is all about quality within the factory. So that's the use of vision systems, and then vision systems comparing to real environment, or again comparing to big data in a cloud environment, or it can just again be data off production lines and just looking for where there is something that's quite an anomaly. So really using data and predictive in terms of getting the quality through the manufacturing process. Absolutely right. So that's another area. And the area that I think is actually the biggest opportunity in the whole of this sort of AI data in the manufacturing world is the whole integrated supply chain. So that is the whole managing right the way from where the consumer is and the demand, managing that through the factory all the way into the supply chain in a much more intelligent way.
Let's come on to that in just a moment, but I just want to talk a little bit more about what you just said about using machine vision and defect detection. So we've seen some reports of Andy Ng's company, The Landing, which is one of the Silicon Valley AI leaders, working with Foxconn and Apple to do defect detection in motherboards for iPhones in the Foxconn factory. Yeah. The thing and I sat down with him a year ago actually and talked to him about that, and one of the reasons he said that they'd gone so quickly to that option was because it was less disruptive. It was something that they could add to existing processes, and it wasn't going to disrupt the way that the rest of production actually worked. Is that part of the issue in terms of trying to prove the business case? That if you can do things that are additional to what's already going on, then that's an easier option to win out in a board.
Yeah, absolutely. And I think that is why that sort of quality defect, better prediction of that, and the first category I talked about of predictive maintenance, those two are and will take off quite quickly because they aren't disrupting that much. When you start to get into the supply chain, right, then I think potentially you are disrupting processes a little bit more, and it's just more complicated.
And because it seems to me that very often when we talk to businesses, one of the challenges that they seem to have is how do they make the business case for the investment in the very right at the beginning of this, and particularly where the companies have existing data flows where the data is not clean. Yeah. And they need to spend quite a lot of time just wrangling the data just to get it into a state before they can even apply an AI process to it. Is that something that you've seen as well?
Yeah, absolutely. And this is particularly difficult for sort of manufacturing companies and manufacturing mindset. And we're struggling with it in Siemens, to be honest with you, because historically we would only ever invest in technology if there was a very clear business case. And by the way, for something like predictive maintenance and whatever, you can write those business cases. But in this whole space, the technology is moving so fast. There are certain times you've just got to have a bit of a belief. I mean, you've got to have a vision that there is something that you can derive value from. But sometimes you do just have to take a leap of faith. And you've got to create sandpits for people and say, look, we think there's some value to be derived from using some robotics system, combining that with some big data and seeing what we can create out of that without upfront knowing the business case. And of course, this is where we as manufacturers can learn from the tech world, because the tech world, sometimes goes into these things, derives its technology, obviously has an idea of the sort of business model, but knows that certain new business models will emerge as the technology emerges.
This is about a shift in mindset, isn't it? And it's about not thinking about things, engineers, and I guess Siemens started out primarily as an engineering business and is now becoming more of a technology business, just as one example. But the mindset of an engineer tends to be, I'm going to make this thing work soup to nuts. It's going to, from start to finish, I'm going to know what it does, and then I'm going to manufacture it. And in the software world and in the tech world, we don't function like that at all. It's much more iterative. We kind of have a sense of where we're going, and we try and get there. And quite often we end up going in a completely different direction. How do we get more of that willingness to have that leap of faith into these very traditional businesses? Because that seems to be in some ways the biggest barrier, actually.
Well, I mean, I think probably the best way to do it is exactly what we're doing here, which is to create the conversations, the ecosystems, to bring the tech sector together with the manufacturing sector more, to jointly have sandpits, to have places like the Digital Catapult where we can come and we can play and we can experiment. Now, having said that, at some point, once you've done your experimenting, you've derived a new business case, you've got a new way of running a process, you then still in the manufacturing world have to find a way of scaling it and making sure that what the engineer does best, which is to make sure that, this will work right first time when it gets out into the market. It's got all of the quality stamps in it. It meets all of the regulation, and all those sorts of things still have to be met. So you almost need to switch your company into sort of two mindsets. One is the new and the experimental, but you also need to still be able to have the team that can then really scale that properly into the commercial world without taking any risks there. Take wind turbines. You can do all sorts of experimentation, but when your wind turbine is out there, it damn well needs to work, and it needs to be safe.
Right. So is this where Made Smarter comes in as well? Is this where intelligent use of small amounts of public money start to make a difference, do you think?
Yeah, well, what Made Smarter is all about, it's about three things. But the first thing is about just showing leadership and making sure as a nation we really get behind digital manufacturing and the fourth industrial revolution. That's one important thing. The second thing...
But you've done that on your own.
No, absolutely. The more people that join in, the better it is. We need to create a great movement here for this country having a great ambition for the fourth industrial revolution. The key bit of Made Smarter that we're talking about here is how do we create demonstrators, how do we create sandpits for people to develop digital applications that once we've sandpitted them, once we've done some research innovation work, we can create pretty standardized models that come out of it. So in other words, how can we, in a fairly simple way, create the digital twin of my manufacturing process? How do I do that? Now, to a large company like Siemens, we're doing that. But if you're a small to medium-sized company, that's, where do you start? And so the whole idea of Made Smarter is to sort of almost come out with quite ready-made, oven-ready, here's how you could start creating a digital twin of your manufacturing process. Just one example.
And is that where in that sort of context, you see AI as being one of the technologies that's involved, but not necessarily the only one?
No, absolutely.
So it's a combination of different pieces. But you touched on something that is clear, that when we talk to a lot of businesses, one of the challenges that they have is they see all these vendors throwing all these propositions at them, and this one's got their AI proposition, and this one's got the VR one, and this one's saying put 5G into your factory and everything will be sorted. How do they work out where to start, these guys?
And it's very difficult, which is again, so part of the Made Smarter activity is to create it'll be a group of industry people working together, but it will be trusted people. So there will be technology suppliers, but there'll be end users, there'll be small to medium size, and of course there'll be experts and consultants within that group of people. So that over time, when especially a small to medium sized company goes to say, right, I want to adopt robotics or additive manufacturing or data analytics within my factory, they feel confident that they can go to a group of people, happen to be called Made Smarter, and they can give them advice, but also a little bit support of how they can start adopting this technology in their factories.
So we've had a pilot in the Northwest announced. Is there anything else that you can tell us about what's coming down the line in terms of opportunities for companies to get involved?
Well, all eyes are on the pilot in the Northwest to see how this goes. In parallel, we are investing in a national initiative to create some of these sandpits and demonstrators for a few key themes. That's some money we've received through the Industrial Challenge Strategy Fund, so about 150 million government money in that we are matching with industry money. The Digital Catapult, High Value Manufacturing Catapult will get involved. And then the plan is to start scaling it. So we've done the Northwest, let's do the Southwest, let's go somewhere else, and let's create the sort of technology incubators.
Was that a tip or just an example?
That was just an example.
Just in case there's anyone from the Southwest in the audience. One final question, and then we're out of time. One of the things that we did at Digital Catapult recently was we did a survey of early stage deep tech companies. And looked at, which ones of them were actually interested in which sectors. And one of the things that came out very strongly was the fact that there were very few of them as a percentage. I mean, fewer than 5% of the companies that we interviewed had an application or were focused on manufacturing. What can we do about that? And we're going to have a panel in a minute that's going to go into this with a bit more detail with a few representatives of companies like that. But just before we get to that, I just wondered, what do we need to do? How do we bridge that gap?
First of all, that is a fact, and it's something I often talk about. You say when we talk about this whole week of Tech Week and CogX happening here, it's all about celebrating tech and startups, and there's some brilliant things happening. But you are right. When you look at deep tech specifically for manufacturing, there are other countries which are doing better than we are. Now, I think we're missing a bit of a trick, and the trick is that actually we can learn an awful lot from where we are strong and bring that into manufacturing. One of the things that I think is really interesting about the Digital Catapult, as just having joined, is the fact that it has a focus on creative and on manufacturing industries. Now, where is a lot of the tech being developed around augmented and virtual reality? Actually, a lot of it comes out of creative gaming type of applications, and from there we can transfer at speed into a manufacturing commercial environment, and we're not doing that well enough. So we need to.
We need to do something about it's about cultural bridge building as much as it is about the technology itself, isn't it?
It is.
So, any other thoughts about how we create that sort of crossover culture? How do we create that fusion between these different areas? If you saw this morning how few manufacturers there actually are in the room here, because this is CogX, which is great, but it sort of highlights the challenge in a way, doesn't it?
Yeah, and hopefully what it highlights is that there is people here from the tech sector who are interested in looking, how can I get more involved in the manufacturing sector? And I do think there is a bit of a void, and I think we'll talk about this on the next panel. You've got manufacturers who sort of think, all this tech startup stuff, it's not quite scalable and it's not ready enough and it wouldn't work in a manufacturing, a little bit of sort of manufacturing engineering snobbery. And on the other side, you've got tech companies, who probably, are underestimating what is really required in terms of scaling this stuff up, and really people just need to get together and talk and make it work, because we know where it has been done, it can be done, and it's very successful.
Excellent. Well, that is exactly what you're going to do in the next panel, is get together and talk about it. So for now, Juergen, thank you very much indeed. Thank you, everyone.
See you later.
Right. Thank you very much. I think for me, the one big takeaway from that panel was the change in mindset. I think that's very interesting, that the more traditional manufacturing industries and the engineering culture really having to change your mindset. So with that, the next panel, we're going to really delve a bit deeper into that. And in this case, I'm going to introduce the moderator of the panel, and I'll leave it to her to introduce the panel. But we've got Maria Nelson, who's a senior head of innovation practice at the Digital Catapult. And you lead the Open Innovation Program, is that right?
Yes, that's right.
And you work with commercial clients and innovation programs, supporting businesses large and small in innovation. So I'm really looking forward to this panel. And then, of course, in standard style, the quirky fact about you is Maria used to be a one-woman musical comedian. and she would do it only in German. So maybe if we're lucky, we'll get that
Very
kind of-
serious music.
Yeah, well, so hopefully, luckily, we'll get that in the beginning. So with that, can I invite the speakers to stage, please?
Thank you. Actually, you're keeping that, I think. You're keeping that. Thank you. Yes, indeed. So I'm also a part of Digital Catapult. We're a little bit of a Digital Catapult crew this morning. What my team and I do is essentially we work with startups and we design and deliver programs that help the startups scale, very targeted programs that help them remove barriers to growth. And then we work with commercial clients to help them adopt advanced digital technologies. So my team and I are smack in the middle of that cultural divide between small companies and large incumbent industrial companies. And so I'm very, very excited to have both on the panel this morning. We have an excellent selection of some of the very few, as we said, just about 4 companies that do AI in manufacturing in the UK. And so please help me welcome Dolores, who is the strategic director from Total Control Pro, which always wants me, always going to go street with that, Total Control Pro. So Dolores, welcome.
Thank you.
Then we have Tristan, who is the CEO of Chai. And we have Asim, who is the business development director of Smartia. And I would actually just like to ask you to introduce yourselves, tell us a little bit about your company and the one thing that is really going to disrupt manufacturing, the one thing AI that's really going to make a difference.
So my name is Dolores Sanders. I am one of the founders of Total Control Pro, and I am a woman in manufacturing and technology, and I focus on engineering and manufacturing companies. So I am a complete minority in every aspect.
Yeah, champion.
But my background is I grew up in manufacturing. My parents ran their own print shop that expanded and became. I know the issues of challenge of that. I then went and studied in psychology and neural networks, so my background is the cognitive side of things and linking that up in providing technology for manufacturing. But our absolute passion is focusing on real intelligence before artificial intelligence, so capturing the skills, the learning, the knowledge, the huge legacy of intelligence we have on our shop floor, and of our British manufacturing, to actually capture that into models that we can start to scale and react and get those minimal viable products, not just in technology, but in the manufacturing products for the future.
And what do you think is going to be the one radical change that AI can make to manufacturing?
I think it's the radical change it can make is shifting our focus from, I don't know if it's radical, but we have a massive intelligence. Mm-hmm. And I think it's allowing and freeing those who are working on the shop floor to be who they are, to be self-expressed in manufacturing. And I think AI can open up manufacturing to be the technology and the industry that people want to join. I want to see people going, not I want to be a lawyer or a doctor or even a technical scientist, but I want to go into manufacturing and I want to be using the Earth's resources, all of our resources more effectively, and I think AI will open that up.
Amazing, thank you.
I mean, just as a quick, because I think it is a big shift, because if I look at our factories and if we try and replicate a manufacturing process from one to another, the only way we can really do that at the moment is with the knowledge that is in people's minds. We might have documented some of it, but actually the corporate memory, as we call it, in terms of getting that from one into another, is pretty poor.
Yeah.
And if we can use AI and data to help with that corporate memory and put what we know from one to the other, the shift is huge.
Yeah, absolutely.
Tristan, what do you think?
Hi, so I'm Tristan, co-founder of Chai, and we exist to help companies navigate the volatility of raw materials in their supply chains. We use machine learning and AI to look at lots of interesting time series like satellite data, the movement of boats, and more pedestrian economic data sets, and try and predict commodity prices in the future. And that helps companies work out how much they should be paying for their prices, for the raw materials they ingest, and hence become price makers instead of price takers in the global marketplace. In terms of where I think AI is going to most impact manufacturing, I'm obviously slightly biased here given the set up company to do this, but you mentioned earlier integrated supply chains. And I think at the moment the world is doing everything it can to disintermediate supply chains. We're hearing what's happening with trade protectionism and trade wars. is making many very well-known supply chains like Toyota's, which is probably the tightest and most famous one, disintegrate. And if we can help use AI to predict prices, to navigate how those prices are going to change, and in between those factory floors you're talking about, build that connection back, we can actually reverse that trend a little bit. And I think that's where Chai steps in and AI steps in with my lens of that world.
Good.
Good. My name's Asim Majid, and I am the Business Development Director, but also the co-founder of Smartia. We're an industrial AI software and services company. And what we're trying to do is help manufacturing engineering companies do something with their data, find the value through using machine learning. When we talk AI, we're very focused on machine learning. We're not specific in terms of what kind of machine learning applications we develop, because there's so many different use cases out there. But what we try and do is help, especially these small to medium-sized companies, access their data. So we have a product called Maier that has a hardware aspect. We're hardware agnostic, so that actually connects to their industrial machines, pulls that data through to a central area. It might be cloud-based, it might be on-premise, and actually gives them access to the data, bringing in data from other systems as well. So we are aiming to help companies start the journey on adopting these type of technologies that have been mentioned. And the first part of that for us is to how can we get them to start collecting the data that's going to be valuable for them. In terms of machine learning applications, we've developed predictive maintenance, as that's been mentioned, looking at computer vision applications, condition monitoring. So these are quite common ones. And I think how AI is going to impact manufacturing is in the same way it's impacted financial, retail. Until the manufacturing start to get the trust in the data, and then in the applications that use that data to pull the value through, it'll be, I think, still early days for that. But once that's, for example, predictive maintenance is something that's quite common now, and a lot of companies are starting to look at that. And that's because a lot of other companies have started to do that, and it's started to now spread the knowledge of that, the value that comes from that. But once the confidence starts building in the industry, we'll see more and more adoption of this, and that's where the real value will be.
Mm-hmm. Thank you. So we've heard a lot about the massive opportunities, both in your conversation earlier. It can really, hopefully, generate buy-in for people, for workers. We can look at integrated supply chains. Adoption is going to drive it all. So we're talking about the opportunities, but really, how is adoption going?
It's slow. I mean, our focus is the SME marketplace. And we've been in tech and in manufacturing for 10 years, so we've kind of adopted and grow with them. And we know that the cloud-based systems and things were available sort of 3-4 years ago, but the trust was a big element, that trust to bring people through, trusting it's there, and providing the opportunity for people to start small. Where sometimes the big vision is we're going to have to put all these sensors in, we're going to have to put all of this technology in before we even see a difference. So opening up small areas or simple investments that are at a price that manufacturers can understand. Our technology hasn't been priced where they're used to buying a big machine, that this is our investment, and they know what that's going to do. But then the technology, you can't do that because you're needing to iterative design with them and build that with them. So, for us, what we've had to focus on is delivering small modules that can be scaled. They can put in their quality areas, they can put on their basic manufacturing flow, and then they can scale it out across to stand there and appreciate that we have to hold their hand to adoption.
Asim, I think you adjusted your business model essentially to help with adoption because you were facing quite a few challenges. Can you tell us a little bit about that?
Yes, so when we actually made Smarter was part of our decision making, because we've been going for about a year now. And we spoke to probably over 100 companies. My background's engineering manufacturing, so I already had clients from tier 1 down to one-man engineering team. So, and one of the things that we found was they weren't collecting data to actually start to apply machine learning. Why was that? And cost was one of the big issues. There's so many different assets out there. How do you connect to all of them? How do you bring all that together? And it did always go back to the kind of how do we get started, really? we don't want to jump into machine learning because we don't understand what value is in the data, but what is data science, what is machine learning, and how is that going to help? So that's where we decided, actually, if we could help them start the journey, so very low cost, low complexity, a way of starting to collect the data and then use data analytics, use dashboards, and start to look at the data themselves, build that confidence in the data. Then there's lots of fantastic companies out there that can actually help with the machine learning, the data science part, and those applications can then be used to really drive the value from that. What we found was there's a big cultural mind change, that one, it was mentioned earlier, that needs to happen in manufacturing. So if a company wants to invest £250,000 in a machine that makes them some products, that's usually not a problem because they can see an end result of that. Whereas software, which is my background for a long time, is a harder sell really because it's not always tangible. They don't get a product at the end. So it is I guess a more riskier thing. And also a lot of people are used to buying software and not having to pay a huge amount of money for it. At the moment where we are with AI and machine learning, even a few years ago, it's quite an expensive investment without knowing exactly what you're going to get out of it at the end. And it's trying to tweak that cultural mindset to actually, there's more and more examples now, so you can start to use that. So Siemens done great work with MindSphere and some of the applications that have come through that. But it's with, I would say, about 90% of the companies, we're still at that stage where we have to start to get them to be convinced that the data can help them with their day-to-day job.
So there are two massive challenges, essentially data, just even having the data and having it in the right state, and then the cultural challenge of working together. What's your experience in those two?
So I think it's important to look at the adoption rate in manufacturing relative to other industries and understand that in the context of that. And we see machine learning being adopted in financial service probably first because, as you just mentioned, the data was pretty much perfect for those kind of use cases where you could apply these, at the times, or time series analysis algorithms, and the upside was so massive. If you think about sort of asset management and financial trading, you've got a beautifully scalable business. So if you've got something you spend a lot of time just doing an algorithmic change to, you will have a huge amount of results. And then that focus of using machine learning has moved into other sectors where there's been data availability. Medicine was probably the next along that curve. Medical imaging and linking together disparate data sets. And then law more recently with the growth in natural language processing. And manufacturing is kind of this unloved industry that's only coming at the end of that adoption of machine learning in the real world. And I think as a consequence of that, we're seeing slow adoption cycles. And I think the tier one organizations have been using machine learning in their supply chains and their manufacturing processes for a long time. That's actually how I started off my career, using machine learning for Unilever, about 15 years ago now, actually. And I think people have enough budget and enough risk appetite when they're tier one organizations. And the challenge is, in an industry where actually most of the companies, particularly in the UK, are on the S of the SME size of the spectrum, is how do you build something that's addresses their needs and isn't so bespoke that you can accommodate all these different needs for the smaller organizations, perhaps building it out for the early guys who are early adopters and kind of abstracting away their use cases for everyone else.
One thing that is often mentioned and that you also mentioned in a conversation that we had is that kind of scaling up issue, so getting out of proof of concept purgatory. What's your thinking about that? What can we do to help companies progress from those small little initial buy-ins that are really important, but then actually to get to scale?
Yeah, and that is a big challenge. I mean, first of all, before I answer that question specifically, I say that there is actually, if we get this right, the opportunity, I think, is huge, especially in the UK, because actually manufacturing of the third industrial revolution was all about large-scale capital investments, huge robotic systems, huge machine tool systems, tens, 20s, hundreds of millions of investment. And the UK wasn't that good at that. We are actually much better at agile smaller, start, build, and for which this fourth industrial revolution, using all the applications you've just described, I think we're better at. But the one thing that companies do worry about is, okay, so we're starting agile, I'm starting with your solution. How do I know in 2 years' time there isn't something better out there? How do I know that this can be scaled to give me the quality output? So it's for manufacturers to work with, with the tech startup community to say, look, we'll do this step at a time, but we'll design it with scale in mind. So it's sort of one step at a time, but at the end, this has to be scalable. And the other thing is it has to be open architecture, so that at the end of the day, if any of you, you can't stem the whole solution, then we'll bring another partner in at somebody, and they all need to be able to plug in, and we need to be able to develop this as an ecosystem. So that's the thing. It's that trick of agile start, but an eye on how do I scale this.
I think that's why startups are so well placed to help address this, because it's in their DNA to consider scalability. You can't go and speak to an investor if you haven't got that as an end game. And if you're building something that is software as a service or anything of that ilk, a platform, those buzzwords that investors like to hear, you've got this in the back of your mind all the time. So I think there's that marriage between the large organizations who are hopefully paying to use those services, trickling down to the smaller companies as clients. But yeah, it's going to come from the disruptors, probably more likely than some large organizations such as Siemens, spinning something out, is my guess. Yeah. Though I know Siemens have an investment arm who do fun things like this. So.
I think collaboration, that's one of the keys. Is, you talked about building the sandbox. The idea of the sandbox is to encourage children play, to find out different areas, and that collaboration is really key. I just went on a tour actually to Spain to talk about what we were doing, and the conversations we were having at their Be Digital conference were like we had at Industry 4 conference 2 years ago. They're kind of at that stage, and they were really concerned about, looking after data, managing how their machine setups didn't get into the hands of the competitors. It was all about security. Whereas actually, I think in the UK, we've now really got that it's not, yes, we've got some incredible tech to look after our security, but actually our collaboration, sharing that data, having platforms that creates a benchmark for small businesses to go, how do I perform against what's expected? Do I need to do this just to stay, in the game, or what other things can I do? And encouraging, if we have a system where you've got real technology off the shop floor, you know what you're putting through, you can start to put in predictive maintenance and dynamic planning. So given the resources I've got today, are my machines going to be working if I put my maximum load throughput in here today? It has to be the top quality. My clients just said they need this. They need to bring the delivery date forward. Can I shift that around? And it happens dynamically. Are my resources available? Can I buy at the right price so I can deliver to the client at the right price? And to do that, we need a collaborated community to connect that. We cannot all do it alone, but we have to be speaking the same language.
Mm-hmm. And that openness and agility and kind of openness to collaborate is also possibly something that actually sets you apart from the bigger vendors, because, you could always go with somebody bigger who's doing it. So actually that's a real strength in the startup and small company ecosystem.
And that's, sorry. No, Asim, go.
I was just going to say, it's very important that the collaboration side and the open architecture is something that we've heard and we've seen being very important. Because when you're talking to potential customers and manufacturers, they don't really care about what's the technology behind it, because it could be too complex for a lot of people that are going to be using it. So they really want to see what they can do with it, what the solution at the end, and how it's going to help them. They don't really care about what's going on in the background, or how they get the data, or how the data is presented to them. They just want a way very quickly to write, here's the value of the data, I want to do something. So to be able to do that, you need to have an open architecture, because they may have a certain cloud vendor that they want to use, or they want to use a certain database. So you have to have that open community working together that allows you to build that solution for them without them having to then work out how to put it all together. So to provide that solution, you need to have that kind of openness.
I'll ask one more question, and then we'll open up for questions from the audience. So if you want to get your thinking caps on, if you have any questions for the panel. If you had one thing to either tell a manufacturer or a startup that could help with the adoption of AI in manufacturing, what would that be?
I think on my side, it would be bold and take risks on both sides of that. As a startup, have muscular thinking in terms of when you negotiate your proof of concepts, and don't be beaten down by the large organisations just because they have so much revenue and they know what they're doing. It's amazing if you stand your ground in negotiating things like that. Actually, if you don't have much competition for what you do, and that organisation needs your help, you're more likely to help them and the industry as a whole in aggregate if you have stood your ground and you've kind of developed a product with somebody that's more useful for everyone instead of just that client. And vice versa, if you're a large organisation, take the risk of working with the startups before you become outmoded yourself. That's the best way of the whole industry moving forward. It may not be locally optimal, but it's globally optimal.
Mm-hmm. And it's, get started, identify the low-hanging fruit, target that first. Don't tie yourself into anything that's going to be 5 years out. Free yourself up to do a quick project that demonstrates return on investment. Take that to your team to expand it and just get going.
Yeah, similarly. Yeah, so start small. Actually, that's to reduce the risk. And we'd even say, don't even start with the machine learning or the AI. From our point of view, start with the data. Start collecting that data and start using it for small jobs, and just start to incorporate that into your day-to-day, and then we can start talking about how machine learning can help once the trust is there.
Yeah. I think a very quick one, don't try and do it on your own. So reach out, go to a knowledge ecosystem like the Digital Catapult, like your local university. There's lots of these new ecosystems, and join in with others and learn from them, and then apply.
Mm-hmm. And what would you tell other manufacturers to help them adopt that?
Yeah,
or anything in additional to give them a little nudge of...
That's my advice to the manufacturers, join a broader community, and learn from others. Because actually every problem you're trying to resolve in a factory, somebody else somewhere else is trying to resolve.
Yeah.
And then there are a group of startups like this who are thinking themselves into how can I help those people solve the problem. So to try and do it in your own isolated factory, it's just, quite frankly, it's completely bonkers. Just get out there and look for the people who can help you do it.
Which is that shift in cultural mindset, yeah. Thank you very much. Do we have questions from the floor? If you have one, would you mind telling us your name, if you like, your company, and who the question is addressing? Yes, please, the gentleman in the front row. We need a microphone, I suppose. Do we have a microphone?
Don't know what happened to the microphone.
Yeah.
Yeah.
We'll repeat the question now.
All right, we'll repeat the question.
Okay, what I'm worried about is, let's say, approach, you can say, of developing collaboration, etc. What is the sustainability? This is the question. The second question is, what is the economic, let's say, development? How the people are part of the system? Now, all this issue I think it's more technological drive. I would like to see the collaboration between data. That's what is missing. Data is the issue. How you develop an ecosystem based on data, and then from there try to plug the manufacturing or the startups, and the data itself, they should tell me the future. Where shall I go? And therefore create economic and social. I mean, the complexity is about the interaction between economic, social, and environmental driven by the data. This is, I think, what is missing on this. Just focus on manufacturing technology.
Yes, do you have a specific question? Or is it a comment, basically, should all be, so the gentleman's saying there's, more data-driven.
Data are missing.
Yeah.
You are not collaborating using data.
Yeah.
True.
That's the question.
So I can give you one example. It's a real-life example. For one of our customers, they create electronics boards. They knew that to stay competitive, they needed to, if they went literally a minute over in the production of those, it would cost them £40,000, which is one of their members of staff. Putting our system to literally collect people, product, and process on the shop floor, they've been able to understand their production, understand their productivity. Actually, they now run their entire wages and promotion system based on the data from the shop floor, not the shop floor, production manager walking around going, I think they've done a good job, where's she off to? They understand the reality of what's actually happening, and they're being able to, they've shifted now because of understanding their data into not just the oil and gas industry they were in, now into the aerospace industry. So through understanding that pure data, people, product, process, what's really happening, they've been able to expand. They're now looking at more advanced systems, but that core element has to be in place first to build on it.
Yes, but this is economic growth from the company, not from the community itself. I would like to see...
So, excuse me, we've got time for one more question. So can we save the debate for afterwards?
After we have another half hour.
Yeah, afterwards.
After
So
the
meet
panel.
the speakers after. And we have the gentleman back here. And this will be the last question. And it sounds like there's a lot of questions in the audience. So please follow the speakers out to the back and then just have lots of questions back there. We've got a tight schedule, very sadly. So who are you and what do you do?
Okay, I'm one of those few startuppers that actually does something for manufacturing. I'm Radek, and I wanted to know more about Sandbox initiative, because the reason why there are few startups in UK for manufacturing, I would argue, is that investors cannot really understand in manufacturing, and so people go for fintech or biotech, something that's easy to understand, and the Catapult system is only accessible with money. So essentially you cannot even jump on board with Catapults if you don't have that money, and you don't have money, so you basically don't go into manufacturing. But my question is, as I wanted to ask, what is the Sandbox stage and what kind of startups are supposed to be using it?
Okay, just to say about the Catapult and you need money, you don't, I think there might be some misunderstanding there. We can talk about it a bit later if you want. But yeah, if you want to say something about the Sandbox.
Yeah, so, I mean, I think there is some truth. You know, initially, certainly the catapults were built up to do, large, especially the high-value manufacturing catapult was built to do quite large programs with companies like Siemens, Rolls-Royce, and whatever. We are changing that model, and Made Smarter certainly intends to help change that model to allow tech startups, smaller companies to come on board without an entry fee. But I think, your answer is right. We need to be building more of these. We've started building our ecosystem over the last decade in the UK. If you go into Germany, they've got the equivalent Fraunhofer institutes. They've been doing them for the last 50 years. And, so we just need to keep building this movement to create these ecosystems where people can engage. I can quickly just come to the data point, just to acknowledge it and say, look, you're absolutely spot on, and as well as the challenge that we talked about of culture and collaboration and all the rest of it, that exact same thing needs to happen in the space of data and needs to happen to allow these sort of IoT platforms to be able to collect better big data about industrial applications that can be then used by the whole community of manufacturing, and that is a challenge, but there are initiatives that are beginning to address that.
Thank you very much. Thanks for sharing your thoughts. We have plenty of time to continue having the conversation off stage. Thank you for joining us, and have a nice time at CogX.